The planet is heating up.
The oceans are becoming filled with plastic.
Change starts now. Change starts now.
We're on a countdown
To zero waste. 5, 4, 3, 2, 1.
This is the Zero Waste Countdown Podcast. Here's your host, Laura Nash.
Hello, everyone, and welcome to the Zero Waste Countdown podcast and radio show. Today, we're speaking with Susanne Khün from Wageningen Marine Research. She has led a study called Details of Plastic Ingestion and Fiber Contamination in North Sea Fishes, as well as doing an important study on fulmars. Susanne, welcome to the show.
Thank you for having me.
So please tell us where you're from and what kind of research you do.
I'm originally born in Germany, and now I live for more than 10 years in the Netherlands, and I'm working for this privatized research institute, Wageningen Marine Research. What I'm doing is working mainly on not on fulmars. They are known to ingest a lot of plastic, and we try to look at the problem from different angles. That's where the fish comes in, because fulmars, they do eat fish, and maybe they take up plastic via the fish they eat.
Yeah, and on your study with fulmars, did you find that that's where the plastic was coming from, was from their fish diets?
We looked at more than 4,000 fish in the North Sea and another 70 from the Arctic Ocean, another region where fulmars occur. And we only found very little plastic in fish. So in our fish, it's about like 2 to 3% of the fish that contains plastic, and usually the plastic is very, very small, smaller than a millimeter. And when we look at fulmars, like 90% of the fulmars, they have ingested plastic, and the particles are much bigger. They're around like 3, 4, 5 millimeters. So we assume that fish is not a major pathway, so that only little plastic contributes to the plastic load that fulmars actually have.
Mm-hmm. We talked to another scientist who was saying that for humans, when we eat fish, we don't typically eat the stomachs of the fish. So if the fish were eating microplastic, we typically wouldn't eat them on our plates because we're not really eating fish stomachs unless you're eating something small like a sardine or something. Do you think that kind of holds true in terms of birds eating fish, or do they eat fish whole? Do they eat the whole stomach?
Yeah, usually in fulmars, like smaller fish, they ingest completely, so they would get the whole stomach and plastic load in them. But for example, fulmars, they tend to follow fishing vessels, and sometimes on these fishing vessels, they already gut the fish, so therefore all the liver and intestines are thrown overboard. And then of fulmars, they love that kind of food, so they would eat whatever they can get, which is often the liver, because it's very fatty, and obviously also the stomach, because it might be connected to this.
Wow, that's a very good point that I never thought of. So I used to serve in the Canadian Navy, and I watched our cook dump the kitchen scraps out the back of the boat. And typically, if you're just dumping, veggie scraps or little meat scraps or whatever, it's fine. But sometimes I would see plastic being dumped as well. So like maybe a yogurt container got into the food scrap bucket, or some twist ties or wrappers, that kind of thing. So I wonder if the ships are dumping any plastic. That would be the bigger pieces that you're finding in the fulmars.
Yeah, we do find a lot of, for example, pepper bell seeds in fulmar stomachs. And obviously they won't float a sea. But what we think is that they, by following ships, that they get exactly those loads of the kitchen scraps with them. And they are quite smart. They can, like, they know when you're throwing stuff overboard. And what sometimes happens is that this biological waste gets into a grinder first to make it small and compact. And sometimes it happens that also plastic gets into that grinder and then is thrown aboard together with the biological waste. So that would be a pathway indeed for plastics and fulmars.
So you said that it was pepper seeds, like those bell peppers?
Yes, or onion skin, tomato skin. We find grape seeds.
Wow.
olive seeds sometimes. Yeah, yeah.
Yeah. Yeah, I bet there's plastic going off in the kitchen scraps because like I said, I saw it with my own eyes. And the Canadian Navy, we have some of the best environmental regulations in the
Yeah,
world for
yeah.
shipping. So if we're doing it, there's probably some other countries that are
Yes, yes. I
are
mean,
doing it too.
officially, it's forbidden to throw plastic overboard. Luckily,
Yeah.
since a few years by MARPOL, on an international level. But of course, things happen on a ship, and it's a lot of work to maybe put it aside or whatever. So the easiest way, and sometimes obviously incidentally, it happens. Yes.
Yeah, yeah, we would, I don't think it's too intentional. Like we're not just taking all our plastic and dumping
Yeah.
it. It was just ending up in the food and cigarette butts too. There are a lot of people throwing their butts.
Yes, yes,
Do
yes.
you ever
That's
find those in the fulmars as well?
we do find cigarette butts once in a while. However, these cigarette butts are made of cellulose acetate,
Yeah.
and usually they disintegrate very quickly into kind of fibers, and then you don't recognize them as being butts anymore in a fulmar stomach. And they also
Mm.
tend to sink because they're heavier than seawater, so they won't float on the surface, and that's where the fulmar usually is foraging.
Oh, I didn't know that.
Yeah, that's why you find them a lot on beaches, but not in seawater usually.
Hmm. Yeah, because I think initially they'll float, but I guess they don't float very long as soon
No,
as
they
they break
soak
their.
up with water and then they're gone. Yeah.
Yeah. So let's get into your study on fulmars a little bit more. So what did you find when you tested the gastric fluid of the fulmars? I believe you added plastic to the stomach fluid to see kind of what was happening there.
Exactly. Plastic is known for having some additives embedded, so, for example, flame retardants or plasticizers, UV blockers, colors, whatever. And we wanted to know whether these substances do transfer from the plastic into the stomach of fulmars and therefore into the body of fulmars. So we mixed the stomach fluid of fulmars together with the plastic we collected on the beach. So therefore we knew it's like realistic plastic, the plastic that a fulmar would actually eat when being out at sea. And before we used that plastic, we did tons of analysis to see what type of additives are actually in the material. And then we took samples after a few days and after even 3 months to see whether whether the additives transfer to the stomach oil. And what we found is that indeed a lot of different additive types moved from the plastic into the oil of the stomach, what is inside the stomach of the fulmar. So that's quite worrying. Fulmars, because they fly at sea and sometimes they find big schools of fish or something, they have to digest quite quickly, so they make space for more food. So they
Oh.
are quite acid in their stomachs. And what
Hmm.
also plays a role is that fulmars and other albatross-like birds, they produce some kind of oil out of their food. So when processing, when digesting, for example, fish, they keep some oil out of the fish in their stomach. And oil is known to kind of extract some substances out of other materials, so that even makes the fulmar more susceptible to such effects.
Yeah, I remember hearing that about cans because cans typically have the BPA lining, and we've had people on the show before say that oily foods will get that BPA out into your food from the can more
Yes,
than other types of foods. So, yeah,
water
we've kind of
or whatever. Yeah, yeah, that's true.
yeah, yeah. So is this hurting the fulmar population? Do you think like is this having negative effects?
It's a very difficult question. What we know is that fulmar populations are decreasing in some places quite dramatically. However, there are more factors, for example, climate change, fisheries, other types of pollution that may play a role. So for us, it's really hard to find how much plastic actually contributes to a potential decline in populations. And as long as we are studying birds in the wild, we really don't know how much plastic is contributing, if it is contributing.
I would think that the diets aren't as balanced as they should be as well if the fulmars are following the ships and eating certain parts over and over instead of the full fish. So, like, I think even for humans, you're not supposed to eat too much liver or like too much fat, like you don't want to just have this diet. I mean, maybe because we
Yes.
know that like the Inuit, they had a high fat diet. I don't know, but it just seems like maybe their diet isn't as balanced if they're just eating the
Yeah, I
scraps.
mean, you're having one part that is, for example, that plastic mechanically fills up the stomach, so there's no place for enough food, for example. But of course, fulmars are top predators, so they eat a lot of other animals, and comparable to the Inuit, for example, they do eat a lot of livers and stuff of other animals. So accumulated substances may end up in fulmars.
Yeah. So I was reading through one of your studies and I saw that plastic was first discovered in seabirds in the 1960s. That's a long time ago. Like we've known about this problem for a long time. Can you tell us a little bit about like do you know anything about the first discovery or anything like do you know when it was in the 1960s?
Yeah, there's been even older records. For example, there's been found a candlestick, which is not plastic, but still like human debris, in, I looked it up, 1838 in a
Wow.
seabird. I mean, this is even before plastic was even invented, actually. And then in the 1960s, let me see, in 1962, there was the first discovery of plastic in storm petrels. Those are real, like tiny little, beautiful seabirds, same family as my fulmars. And those were found in Newfoundland in Canada with some plastic in it. And at the like same time, around 1964, there were on the other side of America, on Hawaii, Laysan albatrosses that were found with bottle caps and other types of plastic in their stomachs as well. So they also belong to the same family. So the tube noses, those are the fulmars, the albatrosses and stuff that do have those tubes on the nose, that they're really prone to plastic ingestion, even in the old days.
We talked to Dr. Denise Hardesty.
Mhm.
So she was telling us about the study on the seabirds as well. What were those little ones called again? Uh,
Storm petrels?
Storm petrels. Yeah, she's done a lot of work on those, I think. Yeah. That was episode, if you're listening, it's episode 105 called Plastic and Marine Life. There's a lot of information in that episode as well about sea life and plastic and what it's doing to marine animals and stuff like that. So the other question I wanted to ask you about seabirds. So it looks like you developed these 3 methods to analyze plastic in seabirds. So can you tell us what those 3 methods are?
Yes, I didn't develop them. I'm like,
Oh,
those were developed in the early 2000s or maybe even earlier, usually for diet studies.
mm-hmm.
And after a while, they started finding plastic as well, so they used those as well. I just described them or summarized them, so I didn't do that. But the usual way is that we actually dissect birds, and those birds most of the time come, for example, from beaches or something. They die because we usually of starvation, for example. We don't know whether it has to do with plastic or not. In most cases, we don't think so. So we find them dead on the beach and we take them to the lab and then we cut them open and take out their stomach and look into the stomach. This has the advantage that we can actually have a look at body condition, for example, that we can have a look at the cause of death, if we can find some signs, for example, for bycatch or for collision or whatever, and that we usually can reveal the gender and the age of a bird, whether it's a young or an adult bird. And the other 2 methods would be, for example, that you force live birds to vomit, actually. Therefore, you have to catch a bird. And what you can do is either give them emetics or put a pipe in their throat, and then let them vomit and collect the content and see what's in there. That can be handy because you can select certain birds you would like to look at. Has of course the disadvantage that you have to handle a live bird, which is of course stressful for the bird itself, and that you may only get part of the stomach content because you don't know whether you have all of it. And the third one that's usually used is some birds, for example, land birds, owls are known to do that. At the end of the day, they collect all the indigestible prey items and puke them so regurgitate them, and you can actually collect those pellets and see what's inside. Gulls do that a lot. Cormorants do that a lot as well. Fulmars and albatrosses don't. So you're restricted to a certain species if you use that method. And again, you don't know if you have the complete stomach content in that bolus.
Mm-hmm. So if you're listening in the Belleville area here in Canada, you may have went to the Frink Center. And when I was a little girl, I remember picking through the owl pellets, and I thought it was the neatest thing. So all of us kids, I don't know if they still do this. I feel like they probably don't anymore. But we would pick apart all the fur, and you could find the little bones, and we were
Mhm.
trying to piece together the bones of like mice or something, right? We were kind of like trading
Yep.
bones, and it was really neat. So I assume you've been thrown up. Birds have thrown up on you quite a bit.
Yes, yes, they do so. When you handle them, some of them use it as a defense mechanism.
Mm-hmm.
But usually you can go into a gull colony and there will be those boluses or pellets indeed, and you can just collect them. They are quite like firm. It's easy to just pick them up, and at home indeed you can just pull them apart and see fur and bones. And especially in gulls, they do forage a lot on landfill, so you can find chicken bones or spare ribs. Or a colleague of mine actually found a mobile phone, so everything is possible.
Oh my gosh. So this is really fascinating stuff on the fulmars. I wanted to go into talking about your study on fish
Mhm.
populations in the North Sea. So I noticed you found airborne fiber contamination in fish populations in the North Sea. So can
Mhm.
you tell us how you knew they were airborne?
That's not easy, and that is the main problem because usually we cannot distinguish them. Once they are in the sample, we don't know whether the fish has ingested those fibers or whether they come from the air. But what we did is putting some control dishes next to our sample and then check the amount of fibers in there, because then we know for sure it's from the air. And then we can calculate how much fibers are actually in the ambient air and how much may be in the stomach. And what we found is that in our case, and that may differ for each lab, there were almost more fibers in the control than in our samples, which means that most of the fibers in the samples are probably from the air and not from our fish.
Oh, so they would be from your lab.
Hmm. Yes.
Yeah.
Yes.
Yeah.
Yeah.
They're all
Yeah,
around
but
us now, I guess.
exactly. Yeah, wherever you go, whenever you eat your pizza, there will be fibers on top of it because they are in the air and they just land on wherever you are.
I really worry about them getting into our alveoli.
As soon as you breathe dust, you will get those fibers in your body. But usually, lungs are trained for collecting little particles that do not belong in the lungs. So they probably used to those the slimy part that so they know how to get rid of it again. But of course, there may be the chance that they get into the lungs and may have an effect. We don't know.
That makes me feel a little bit better to know that we've got a defense mechanism already against
Yes,
this
yes.
stuff. So the fish species, were there certain species that tested higher for plastic than other species?
In our studies, we found that actually cod was one that had quite a high incidence, and in our study it was like 12%. Just it's still very low in compared to fulmars that had 90%. But all the other fishes were even lower at 2%. So there is a difference, and I mean there are many explanations why this might differ. It might be the foraging technique, that the fish that is like, for example, flatfish that is on the sediment might ingest a different amount of plastic than a fish that is in swimming in the water column, or for example, a fish that is really hunting specifically for smaller fish or copepods may have a different load than fish that is filtering the water. So
Mm-hmm.
I cannot give you a good explanation for those differences, but they seem to be there.
When you say 90% for fulmars and 12% for cod, does that mean 90% of all fulmars you studied have plastic in them?
In the North Sea, yes.
Okay, yeah. And so 12% of all cod that you
Hmm.
studied, you would find that they had some plastic in them.
That's
Okay.
also for our data. Yeah.
Yeah. And how did latitude affect plastic uptake by fish?
does, and I think it does in the sense of urbanization and ocean currents. So you can imagine the North Sea is one of the busiest areas in the world with a lot of traffic, shipping traffic, and a lot of people living around the coast. And when you move a bit northwards, for example, to Iceland or to Greenland, to northern Canada as well, you find much less plastic. And on Iceland, it's only 80%, and Arctic Canada, it's as low as 40% of the birds that have plastics.
So the more south you go in the North Sea, the worse the plastic is?
You can see it on the small scale as well. So, for example, the Channel area between France and the UK is more polluted than the more northern parts of the North Sea. But you can also see it on a big scale with like the North Sea against the Arctic Ocean.
I've worried about accumulation. So we've talked before that the plastic and contaminants and stuff can kind of get shuttled up to the Arctic.
Mhm.
Did you see that at all?
What we saw, we studied fulmars on Svalbard. That's like half the way
Mhm.
between northern Norway and Greenland, very high up. So we expected a very low plastic load in the fulmars. But what we found was higher than on lower latitudes, for example, in Iceland. And our explanation for that finding was that there are some currents going from the South Atlantic, or the southern part of the North Atlantic, I have to say, going northwards, and they are actually passing by Iceland and then moving to Svalbard. And other researchers, they think that there's even like another plastic garbage patch in the Barents Sea close to Svalbard, which may explain the high numbers. So I think currents, they play a major role in the distribution of plastics.
Mm-hmm. Yeah, they take it away from us and then
Hmm.
kind of put it up to the Arctic, which is a
Exactly.
little unfair, I guess, for everything that's
Yes.
living up there
Yeah.
and the people too, right?
Hmm.
So, yeah. Did fish near the coast test higher for plastic uptake?
Other researchers found that. However, in our studies, we couldn't find a relationship. So there was no difference whether they were far away from the coast or close by. But this
Mm-hmm.
again may have to do with currents in a certain marine system.
Yeah, that's sort of what you'd think is that the plastic would kind of hang around there. But yeah, if you've ever watched the tide go in and out, you can see that the ocean's very strong and that there or if you've ever tried to kayak somewhere and against the
Yeah,
tide, you
yeah,
can
there's no
see how
way. Yeah.
strong. Yeah. Yeah. So what did you find about wintertime as well? I read that the plastic that's being ingested might be different in wintertime. Can you tell us about how you found that and if you have any ideas why that would be?
Yeah, we found that pattern in fish. And what we think is causing this is actually the foraging ecology of fish. So some fish, they tend to stop foraging in winter, and that would explain why you have less plastic at that time in their stomachs.
Do they just not eat in the winter?
Yeah,
Really? They like kind of go into some fish hibernation or something?
yeah. I mean, they still move and swim around, but there were many studies I've looked it up that say that in winters they don't eat much.
Wow, that's very interesting. I didn't know that.
Yeah.
Huh. So, do you have any good news from your studies?
Actually, we do have. My colleague and I, he actually started this program of studying fulmars in the 1980s, and now we're working on it together. And what we see since like maybe 5 6 years is actually a decrease of plastic in fulmars, and fulmars are thought to mirror the amount of plastic in the ocean, so they're quite useful monitor species to us. And there seems to be less plastic in the stomach than it was like 5 or 10 years ago, which means that the ocean is becoming cleaner. And I think this has to do with all the awareness we are all raising in public, and the like better regulations of plastic waste. So I think this is quite good news. It means that all our efforts are actually working.
That's awesome to hear.
it's not a quick progress, obviously. I mean, you're throwing plastic into the ocean for the last 60 years, so it will not disappear within a few years. But I think we are on a good way, and if we continue doing our best efforts to reduce plastic, that should actually work the right way.
That's amazing. That's some really good news. I always like to include good news on the show. And it's wonderful that you're doing this research, and I know there are a lot of young people who listen to the show and they might be interested in going into science, and I think this is a great example of you doing some really good work and then, seeing that there is hope. I think I see this a lot with climate change. People just get so hopeless about it, but there are things that we can do, and especially when it comes to plastic and waste reduction, it's something that we can take control of in our lives, and we can just choose not to buy,
Mhm.
frivolous plastic packaging. So,
Yeah, I think a good example is actually oil pollution. Like here in the 1980s, if you would walk the beaches, you always encountered patches of oil. You couldn't probably walk the beach without having it on your feet or on your shoes. And we also found like many seabirds with oil in their feathers. And like the sources, of course, were as broad as they are nowadays with plastic. And with a few very good regulations and the implementation of it, it was reduced. And nowadays, less than 5% of the seabirds have oil in their feathers. And the type of chronic pollution, at least here in our region, completely disappeared. We do have some spills once in a while, but this continuous input of oil has almost disappeared. And it took again like 10, 20 years to see that effect, but it is there, and it is there within a generation. So I think this is really good news, and I hope the same will happen for plastic pollution actually.
that's great. And that must have been like anti-dumping rules or something.
Yes, yeah, and it was forbidden to clean your tanks at sea, and the ship constructions were much better to prevent spills, and also the harbors, they implemented a lot of rules of how to prevent oil spilling all the time.
hmm I heard a story from another sailor that they were in a different country and the other ships were just dumping their black water, which is like the sewage, right, of a
Mhm.
ship. They're just dumping the black water into the ocean. But Canada has this rule where we will go with the most strict environmental policies. So if we're in a country with rules that are more strict than ours, we will follow theirs. If we are in a country with less strict environmental rules, then we will follow our own. So our ships called a truck to have the black water pumped so that we could properly dispose of it. And then someone on the ship watched as the truck drove away a few kilometers and then dumped it into the ocean.
Mm. Yeah, of course, you always have those few that don't comply with the rules, but I think those rules started because of all the oil pollution on beaches and also in birds. So I think this is the result of year-long work, and nowadays you can see that most of the time it works well.
Yeah, and it's so good. I'm really happy to hear this. And there is a lot of good news in the environment. You just kind of have to look for it because a lot of environmental companies kind of make their money by scaring people, and so they're always trying to make everything look as bad as they can. But I really like to talk to people like you, Suzanne, because there are some good things, right? There's hope, but we have to work, right? We can't just sit back and say, okay, government, you do everything. Like
No, no, no.
yeah, there is work to do. So if you can go get a job in science or policy or even inventing different things in
Yeah.
engineering or something, all these
Yeah,
things,
designing packaging, for example, that is easy to recycle, that would be a big step forward.
a big help. Yeah, absolutely. How did you get into studying fulmars?
During my bachelor studies, I did an internship at a research institute that studied the distribution of seabirds. So I've been out on ships a lot and counting seabirds in the North Sea. And there I met the fulmar, and actually it was the most beautiful bird I could think of. Still think it's the case. And at the same time, they were also studying plastic ingestion in fulmar. So I got really intrigued, and then I contacted my supervisor here in the Netherlands. And he didn't want to have a student actually because it's a lot of work. But we agreed that if I could collect some samples on Iceland, a place where they didn't have data so far, that it would be okay to work with him. So I went to Iceland for my studies, and I was able to find those birds. And then he had to supervise me, and it worked out really well. So until now, we're still working together, and I never stopped studying fulmars, and I'm still very, very happy with that.
That's awesome. And I put that photo of you holding the fulmar. I'll put that up on Instagram in the show notes too. So if you're listening, you can take a look at that, or you can just Google and see what they look like if you're interested. Do you have anything else to add to the show, or anything you'd like to say to listeners who are interested in reducing plastic and interested in the environment?
Yeah, I think it's not only your own responsibility. It's on different levels. Like with almost all environmental issues, you have to work on your own behavior, but also producers, also policymakers, they have to do their own share. So it's working together, and I think that's true for all levels.
Yeah, there's a lot that we can do, and I don't think it's just one simple little solution. I think
You
it's
know,
many,
they all go
many
together,
different.
yeah, and they don't exclude each other. They have to work together.
Yeah, I think so too. Awesome. Well, this has been great, Susanne. So thank you for all the work that you do, and thank you so much for coming on the show and speaking with us today.
It was a pleasure.
That was Susanne Khün from Wageningen Marine Research.
Change starts now.
This is the Zero Waste Countdown Podcast.